coordinate transformation. I am discussing the coordinate transformation as an introduction to canonical transformation, because canonical transformation is a coordinate transformation, but it is a special kind of coordinate transformation. So understanding the coordinate transformation will really help you to understand the canonical transformation. Okay, let us consider a Cartesian coordinate system. So it is xy coordinate system, and I am considering a rectangle area in this coordinate system. That is, if this side is dx and this side is dy, then the area A will be equal to dx dy. Everyone knows these things, right? Now I am transforming this coordinate system to another coordinate system, that is plane polar coordinate system. So the coordinates are r and theta. And when I am transforming this area in Cartesian coordinate system to another coordinate system, its shape will be something different. So I am calling this area as dA prime. And here I told you the elemental area dA is equal to dx dy. In a similar fashion, what will be the dA prime? It should be equal to dr d theta. But there is a problem. This dA element should not be equal to dA prime. That is, dA is dx dy should not be equal to dr d theta. But they are equal if dA is equal to j dA prime. So we can connect these two areas through a Jacobian. That is, dx dy will be equal to j dr d theta, where this Jacobian j is defined as dou xy by dou r theta. That is equal to determinant of dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. I think you are already familiar with this term. This is nothing but Poisson bracket of xy with respect to r theta. So the elemental area in both the coordinate system are connected through a Jacobian. And this Jacobian will be different for different coordinate transformation. I show you one example. Earlier we got the coordinate transformation between Cartesian and polar. That is, dx dy is equal to Jacobian dr d theta. And I told you the Jacobian is equal to dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. Is nothing but Poisson bracket of x and y. And here we know the relation between Cartesian and the polar coordinate system. That is, in Cartesian coordinate system, x is equal to r cos theta in polar and y is equal to r sin theta in polar. So what will be the Jacobian? Jacobian j equal to dou x by dou r, that is equal to cos theta, and dou x by dou theta, that is minus r sin theta, and dou y by dou r, that is sin theta, and dou y by dou theta, that is r cos theta. So what we get? When finding the determinant of this matrix, we get it is equal to r cos square theta plus r sin square theta, that is equal to r. So we got Jacobian j equal to r. So we can rewrite this dx dy equal to r dr d theta. So the area in Cartesian coordinate and polar coordinates are related through Jacobian. Here Jacobian j is equal to r. In the earlier class, I already told you the various area element in different coordinate system and all, right? A small note for you. Area or volume of different coordinate system are related through Jacobian. Okay. One more example. I am transforming a volume element from Cartesian coordinate system, that is XYZ coordinate system, to spherical polar coordinate system, that is r, theta, phi. Right. So, what is the volume element in Cartesian coordinate system? That is dv equal to dx, dy, dz. And what would be the similar volume element in spherical polar coordinate system? That is dr, d theta, d phi. And you can definitely see this dv is not equal to dv prime. Then how they are connected? They are connected by a Jacobian, that is dv equal to j dv prime. Then what is this? Here the Jacobian j will be equal to dou x by dou r, dou x by dou theta, dou x by dou phi, dou y by dou r, dou y by dou theta, dou y by dou phi, dou z by dou r, dou z by dou theta, dou z by dou phi. So by calculating this Jacobian, you can find out the relation connecting dv and dv prime. And here, what is this relation between x, y and z and r theta phi? You know, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. So substitute this equation in the Jacobian, then you find out the Jacobian j. Please try this by yourself. Don't worry, I tell you the final answer. The final answer will be equal to r square sin theta. So we can connect this two volume element as dx dy dz is equal to r square sin theta dr d theta d phi. So here this is the Jacobian, that is r square sin theta. A small note for you. Area or volume of different coordinate system related through Jacobian j. It is nothing but Poisson bracket, right? Now we can discuss about canonical transformation. Suppose I am considering very generalized coordinates, that is q and p. So the area element in this coordinate system is dA is equal to dq dp. Now I am transforming this to another coordinate system, that is capital Q and capital P. Now the area element will be like this one. So this dA prime is equal to dq dp. But I told you this dA is not equal to dA prime, but they are connected through a Jacobian, that is dA will be equal to j dA prime. And I told you what is Jacobian. It is nothing but a Poisson bracket. That is Poisson bracket of dou Q P by dou QP. That is equal to dou Q by dou Q, dou Q by dou P, dou P by dou Q, dou P by dou P. And if this is equal to 1, that means Jacobian J equal to 1. So this equation will be dA will be equal to dA prime. That is, if Jacobian J equal to 1, then the volume or area will be preserved in the coordinate transformation. And we call such coordinate transformation as canonical transformation. That is, if Jacobian J equal to 1, then such coordinate transformation are called canonical transformation. So to check whether some transformation is canonical or not, you have to check the Poisson bracket. If Poisson bracket is equal to 1, then it will be canonical transformation, and if it is not equal to 1, then it will not be canonical transformation. Okay. A small note. If Poisson bracket equal to 1, then it will be canonical. Okay. Note 2. The transformation in which area or volume is preserved, then such transformation is called canonical transformation. And under canonical transformation, Hamilton's equations are invariant. Okay. See, this one is a previous question, and which one is the answer? Earlier I told you Hamilton's equations are invariant under canonical transformation. Are you remembering? So which one will be the answer? Option D. See, this one is another question, and the question is to find out if this transformation is canonical, then which one will be the option. So they given the capital Q, that is equal to AQ plus BP, and they given capital P, that is equal to CQ plus BP. And we have to check whether the transformation is canonical or not. And we know the condition for a canonical transformation, that is QP will be equal to 1. Poisson bracket of QP will be equal to 1. Or we can rewrite in another way, that is dou Q by dou Q, dou Q by dou P, dou P by dou Q, dou P by dou P. If this is equal to 1, then also it will be canonical. So check dou Q by dou Q. So what we get? We get A. What is dou Q by dou P? We get B. And dou P by dou Q, that is C. And dou P by dou P, that is D. So we get this is equal to AD minus CB. And this one is a canonical transformation if this is equal to 1. So this is the condition. So which one is the correct answer? Option B. In this question, we have to find out which of the following transformation is not canonical. The given QP coordinates are Q is given, Q equal to AQ plus BP, and capital P is given, it is CQ plus DP. Actually, we already done this for the previous question, and we got AD minus BC equal to 1. So option 1 is correct, right? Now we can check for option B, that is Q is equal to Q and capital P equal to small p. So what do you have to do? We have to check the Poisson bracket, that is dou Q by dou Q, dou Q by dou P, dou P by dou Q, dou P by dou P. So what we get? Dou Q by dou Q, that is 1, and dou Q by dou P, that is 0. Then dou P by dou Q, that is 0. Then dou P by dou P, that is 1. So we get this is equal to 1. Now check for option C, that is Q equal to small p and capital P equal to minus Q. Then what we get? Dou Q by dou Q, that is 0. Dou Q by dou P, that is 1. Dou P by dou Q, minus 1. Dou P by dou P, 0. That is we get 0 minus minus 1, that is plus 1. Now option D, that is Q equal to small p and the capital P equal to Q. So what we get? Dou Q by dou Q is 0. Dou Q by dou P is 1. And dou P by dou Q is 1. Dou P by dou P is 0. That is equal to minus 1. So this one is not canonical transformation. So option D is the not canonical transformation. This one is a gate question, and in the question Q is given and P is given, and they are asked to find out if it is a canonical transformation, then what is the value of S and R. Here what are the given generalized coordinate and momentum? That is Q equal to PQ raised to S and P equal to Q raised to R, right? And now if it is a canonical transformation, then dou Q by dou Q, dou Q by dou P, dou P by dou Q, dou P by dou P will be equal to 1. So we have to evaluate these terms, that is dou Q by dou Q. We get S P Q raised to S minus 1, and dou Q by dou P we get Q raised to S, and dou P by dou Q it is R Q raised to R minus 1, and dou P by dou P is 0. So what we get? We get it is equal to 0 minus Q raised to S R Q R raised to minus 1. That is equal to minus R Q raised to S plus R minus 1, right? And if it is a canonical transformation, what we get? This will be equal to 1. So for this equation to be equal to 1, we have to eliminate this Q. And we know Q raised to 0 or any term raised to 0 will be equal to 1. Okay, so this total term is equal to 0. Then we can remove this Q. So this will be equal to 0. That is S plus R minus 1 equal to 0. And here we have a minus R and we have to remove this R. So R should be equal to 1. And to remove this minus sign, this R value should be minus R. So this R value should be equal to minus 1. So substituting this R equal to minus 1 value here. So what we get? S minus 1 minus 1 equal to 0. So we get S equal to 2 and the R equal to minus 1. So option B is the correct answer. So another gate question. Here Q and P is given and specified they are canonical. then what will be the value of alpha? That is the question. So we have to find out the Poisson bracket. Then we have to equate it to 1. So we can find out the alpha value. That is dou q by dou q, dou q by dou p, dou p by dou q, dou p by dou p. So what we get? We get dou q by dou q. See, we get root 2 into 1 by 2 root q into e raised to minus 1 plus 2 alpha, and dou q by dou p is equal to minus root 2 e raised to minus 1 plus 2 alpha sin p. Now dou p by dou q. So what we get? Root 2 into 1 by 2 root q e raised to minus alpha minus 1 sin p. Here I forgot to put this cos p. Okay, and what will be dou p by dou p? That will be equal to root 2 q e raised to minus alpha minus 1 cos p, right? So on multiplying, this root 2, this term and this term will cancels, and root q and 1 by root q will cancels. Similarly, when multiplying this way, this root 2 and this 2 and this root 2 will cancels, and this root q and here I missed one root q, this will cancels. So what we get? We get this is equal to e raised to minus 1 plus 2 alpha into e raised to minus alpha minus 1 cos square p minus into minus, that is plus e raised to minus 1 plus 2 alpha e raised to minus alpha minus 1 sin square p. So this is a common term, right? So we get e raised to minus 1 plus 2 alpha minus 1 equal to 1. Then only it will be canonical, right? That is equal to e raised to minus 2 plus alpha equal to 1. So this total term should be equal to 0. Then only we get e raised to 0 equal to 1. So we get alpha equal to 2. This one is another gate question. And again, q and p are canonical. Then the value of constant a is a simple problem, right? So you have to find out the Poisson bracket and should equate it to 1. Then you can find the answer. That is what we have to find out: dou q by dou q, dou q by dou p, dou p by dou q, dou p by dou p, right? So what we get? This will be equal to dou q by dou q, that is 1, and dou q by dou p, that is 4a, and dou p by dou q, that is 1, and dou p by dou p, that is 2. So we get this is equal to 2 minus 4a, and the question it is specified they are canonical, so this should be equal to 1, right? Therefore 4a equal to 1, therefore a is equal to 1 by 4, that is 0.25. Another gate question. Here also two variables are given, and for canonical, what will be the value of alpha and so what you have to do? You have to find out dou q by dou q, dou q by dou p, dou p by dou q, and dou p by dou p, and we have to equate it to 1, right? That is equal to what we get: dou q by dou q. So we get alpha q raised to alpha minus 1 cos beta p, and what is dou q by dou p? It will be minus q raised to alpha sin beta p into beta, And what will be dou p by dou q? It will be equal to alpha q raised to alpha minus 1 sin beta p. And what will be dou p by dou p? That will be equal to q raised to alpha cos beta p into beta. So what we get? We get alpha q raised to 2 alpha minus 1 cos square beta p into beta plus alpha beta q raised to 2 alpha minus 1 sin square beta p. So for canonical, it should be equal to 1, right? So this is common terms, this 2. So when taking cos square beta p and sin square beta p, we get 1. So we get alpha beta q raised to 2 alpha minus 1 will be equal to 1. Therefore, to remove this q term from here, this 2 alpha minus 1 should be equal to 0. Then only we get q raised to 0 will be equal to 1, right? So what we get? We get alpha equal to 1 by 2. Now if alpha is equal to 1 by 2, then what will be beta? Beta should be equal to 2. Then only we get 1, right? So beta should be equal to 2. So this is the answer. That is option D. This one is a net question. And here a coordinate is given, new coordinate is given, that is q. And they are asked to find out the canonical moment. There is new coordinate, p coordinate. And there is a given one condition, that is it is shifted by time. Here you see q of t is equal to q of t plus tau. Tau is some constant. So it is time is increased by tau. Here also t plus tau, time is increased, right? So when we are finding this p of t time, then also it will be a function of t plus tau. So check, here it is t plus tau, t plus tau. So this may be the option, or here you see this is t plus tau, but here it is t minus tau. So this will not be the option, because there is no time translation symmetry, because here it is increasing, time is increasing to t plus tau, but here time is decreasing. So this is not possible, because we are finding out the canonical momentum conjugate to the coordinate. So in coordinate it is time is increased by tau, then in momentum also the time will be increased by tau. So this one is not possible. And here you see this one is minus tau. So this one is not a possible one. And here it is t plus tau, t plus tau. So A or B will be the correct answer. Now we have to check. Now I am rewriting this equation in a simpler form, because when we are finding out the Poisson bracket, there is no derivative with respect to time. So time coordinate is not important for finding out the Poisson bracket. So I can simplify these values, that is q of t I can written as q plus p. And the given option A I can written as p minus q, and option D I can written as 1 by 2 into p minus q. Now we have to find out the p, capital P. And we know the Poisson bracket of these two terms, that is dou q by dou q, dou q by dou p, dou p by dou q, dou p by dou p will be equal to 1, right? So I am taking the first option. So these are capital P values, right? So what we get, q is given, that is dou q by dou q, we get 1. Now dou q by dou p, we get 1. Now dou p, this is p, right? Dou p by dou q minus 1, and dou p by dou p equal to 1. So what we get? We get 1 plus 1, that is 2. So this is not canonical. transformation. Now we have to check option B. What is it? That is dou q by dou q. That is again 1 and 1. And what is dou p by dou q? Here, now this is our p. So dou p by dou q will be minus 1 by 2, and dou p by dou p will be equal to 1 by 2. So what we get? We get 1 by 2 plus 1 by 2, that is equal to 1. So option D is the correct answer. This one is another net question. So the question is to find out which one of the following transformation is canonical. So q1 p1 is given, q2 p2 is given, and we have to find out the Poisson bracket, right? That is dou q by dou q, dou q by dou p, and dou p by dou q, and dou p by dou p, right? If it is equal to 1, then it will be canonical. Now I am taking the first combination, that is q1 is equal to 1 by root 2 q square, and p1 is equal to 1 by root 2 p square. So what we get? We get dou q by dou q, that is 2 by root 2 q, and dou q by dou p, that is 0, and dou p by dou q is 0, and dou p by dou p is 2 by root 2 p. So what we get? We get 4 by 2, that is 2 q p. Now we have to check the other option, that is q2 and p2. So what we get? Dou q2 by dou q, that is 1 by root 2, and dou q by dou p is again 1 by root 2, and dou p by dou q is minus 1 by root 2, and dou p by dou p is 1 by root 2. So what we get? We get 1 by 2 minus, that is plus 1 by 2. So this will be equal to 1. So the answer is option D, only 2. So this kind of questions are very easy to solve. What you want to remember is, you have to remember the condition for canonical transformation, and you should know how to do these derivations. Then you get 3 marks or sometimes 5 marks. Generating function. You already know about coordinate transformation. What is it? We have a all set of coordinate, some QP coordinate system, and we transform it into new coordinate system, some capital Q, capital P. Right? And in a coordinate transformation, if area or volume is preserved, that is dq dp is equal to dq dp, then we call this is a canonical transformation. That is, if it is a canonical transformation, then Jacobian will be equal to 1, or Poisson bracket QP will be equal to 1. And how we can do this canonical transformation? That is, from QP, an old set of coordinate, to new set of coordinate system. For this transformation, we need a generating function, and canonical transformation is done through a function. It is called generating function. That function will connect the old set of coordinate and the new set of coordinates. So this generating function we call or represent by f. Constructing generating function. We already discussed about action integral, that is S equal to integral t1 to t2 L dt. And for a dynamical system, this should be extremum, that is delta integral t1 to t2 L dt will be equal to 0. This is a constraint imposed on the system by the nature. So the path followed by the system in a dynamical motion will be extremum, that is delta t1 t2 L dt will be equal to 0. And we know the Lagrangian is equal to summation I qi dot pi minus Hamiltonian. So I am using this equation here. So I get integral t1 to t2. I am replacing this L by this equation, that is qi dot p minus h into dt equal to 0. And I am defining a Lagrangian in new coordinate system, that is L prime, that is equal to summation I capital Q dot capital P minus h prime. So I am constructing another equation, that is t1 to t2 capital Q dot P minus h prime dt equal to 0. So this one is L and this one is L prime. And we now gauge invariance. That is L prime is equal to L plus df by dt. So by using all this equation, I can rewrite this equation in another form, that is q dot p minus h minus dou f by dou t will be equal to q dot p minus h prime. Here you can see this is in all set of coordinates and this is in new set of coordinates, and these two are connected by a term, that is f. So I call this f as the generating function. So this generating function will transform the old set of coordinate to new set of coordinates, right? And this generating function f will be a function of q, p, capital Q, capital P. That is, it will be a function of combination of old set of coordinates and new set of coordinates. So we can construct different generating function. So first one is f1. So in constructing f1, we take the combination of q and q. So q, q. So you can see one is old set of coordinate and another is new set of coordinate, right? And another generating function f2 is combination of q and capital P. Here also one is old set of coordinate and one is new set of coordinate. And another function is f3. It will be a combination of small p and capital Q. And another generating function f4 will be function of p and capital P. Now I am going to use this term, that is f1 qq. I am going to find out the relation between all set of coordinates and the new set of coordinates. And I told you the relation connecting all set of coordinates and the new set of coordinates, that is q dot p minus h minus df by dt equal to q dot p minus h prime. Here I am taking this function to RHS of this equation. So I can rewrite this equation as q dot p minus h equal to q dot p minus h prime plus df by dt. And here this function is f1 and this is a function of q, capital Q and t. So I can expand this function. So what we get? We get q dot p minus h equal to q dot p minus h prime plus dou f1 by dou q into dou q by dou t, that is q dot, plus dou f1 by dou q into dou q by dou t, that is q dot, plus dou f1 by dot t. Now I am slightly rearranging this equation, that is q dot p minus q dot p plus h prime equal to dou f1 by dou q into q dot plus dou f1 by dou q into q dot plus h plus dou f by dou t. Here you can see the LHS of equation is equal to RHS of equation. Then the coefficient of q dot should be equal. That is, what is it? Small p equal to dou f1 by dou q, and the coefficient of capital Q dot should be equal. That is, capital P equal to minus dou f1 by dou q, and the remaining term is h prime and h plus dou f by dou t. That is, h prime should be equal to h plus dou f by dou t. Here I tell you one trick to remember these equations. We know the f1 is a function of q, t, right? And this q is all set of coordinate, and here you can see a missing coordinate, that is all set of coordinate is small q, small p. So small p coordinate is missing in the f1, and here this is capital Q, that is one coordinate is missing, that is capital P. That is, new coordinate system is capital Q and a capital P. So in the f1, capital P is missing. Now look into the equations. See, the missing coordinate is here, that is P equal to dou f1 by dou q. Dou q is the present coordinate, right? Another equation. Here this is missing coordinate, and what is it is equal to dou f1 by dou q, that is present coordinate. So the trick to remember this equation is missing coordinate equal to dou f by dou present. And one more thing, for small qi and capital Pi, its sign are negative. See, this one is capital P, so its sign is negative. So by remembering these two conditions, you can memorize all the generative functions, that is f1, f2, f3 and f4. Here we derived only for f1. Similarly, you can derive for f2, f3 and f4. Please try by yourself. It is a work for you. Here I am going to summarize all the generative functions. To remember this generative function, we know two tricks. One is missing coordinate will be equal to dou f by dou present. And second one, small qi and capital Pi are negative. So the general generative function is a function of small q, small p, capital Q and capital P. So from this one we can generate four generative function, that is f1, f2, f3 and f4. And what is f1? f1 is the combination of q and q, that is f1 is q, t. And what is f2? f2 is a combination of q and p, that is q, p, t. And f3 is a function of small p and q. And f4 is the function of small p and capital P and T. So by using these two conditions, we can construct all the equations. That is, here what is the missing coordinate? Missing coordinate is small pi, that will be equal to dou f by dou present. Dou present is q. And this one is small pi, so it will be positive. And what is the another coordinate? Here q is the, what is missing? Capital P. That is equal to dou f by dou present, that is dou q. But it is capital Q, so there will be minus sign. And another one, what is f2? Here what is missing coordinate? That is small pi, that will be equal to dou f2 by dou present, that is dou q. And another one missing is capital Q, that is equal to dou f2 by dou present. And another one missing is small q, that is equal to dou f3 by dou present, that is dou p. And this is small q, and small q will be negative. And what is another missing coordinate? That is capital P. Capital P will be equal to dou f3 by dou present, that is dou q. And it is capital P, so there will be minus sign. And another one missing is small q, that is equal to dou f4 by dou p. And for small q, there will be minus sign. And another one is missing coordinate is capital Q, that is equal to dou f4 by dou present. So here you can see this equation is positive, this is negative. Here both are positive, this is both are negative, and this is negative, and this one is positive. So you can see, and you can see for f2 it is all positive, f3 it is all negative. Okay, so remember these equations, it is very important. See, in this question generating function is given and it is in the form of q, q, t, right? So how to find out the relation between q, p, capital Q and capital P? We know first condition is missing coordinate equal to dou f by dou present. Another one, small q and capital P will be negative. So if you know these two conditions, don't want to remember all the four equations. You just remember these two conditions, so you can generate any generative function. Okay, see what is the missing coordinate here? Here q is there, but missing is p. That is the all set of coordinate system in which p is missing in the f. And here this is a new set of coordinate system, and here capital P is missing. So by the first condition, that is missing coordinate, that is small p equal to dou f by dou present. What is present? That is dou q. And another one, what is the missing coordinate? Capital P. What is the present? That is dou f by dou capital Q. And now use the second condition, that is small q and capital P are negative. So this will be negative. So you can easily construct any relation between QP, capital Q and the capital P. So remember these two conditions. It's very important. Okay. Generating function and canonical transformation. Under this section, CSIR will ask two types of question. Type 1, in the question, they will given a generating function and then ask to find out the canonical transformation. And type 2, they will give a canonical transformation and they ask to find out generating function. So these two types of questions will be there in the CSIR exams. First we are going to discuss about the type 1 problems. That is, generating function is given and we have to find out canonical transformation. One example problem. Generating function is given, that is f equal to q e raised to capital Q. Find canonical transformation. To find out the canonical transformation, we have to know the generating function. Here, which is the generating function? This is a function of q and capital Q and t. So we know a function of q capital Q t is f1, right? So the given function is f1qqt. For this generative function, we know the missing coordinate is small p and the capital P. So we get small p, that is missing coordinate, is equal to dou f1 by dou present, that is dou q. So what we get here, this is f1 and that is equal to q e raised to q. So when we are taking dou f1 by dou q, we get e raised to q. And the another missing coordinate is capital P, and for capital P we know there will be a minus sign. So minus dou f1 by dou present, that is dou q. So what we get? We get minus q e raised to q. We can rearrange this equation, that is q is equal to minus p by e raised to q or e raised to minus q. So here you see this is small p. So this is the old coordinate system and this one is new coordinate system. So old coordinate system can be converted to a new coordinate system by using this generative function. And here it is old coordinate system and is converted to or transformed to new coordinate system, that is capital P and a capital Q. And this transformation will be canonical also. Example 2. The given generative function is equal to capital P tan Q. We have to find out the canonical transformation. See, this generative function f is a function of small q and a capital P. So what will be the corresponding generative function? It will be f of small q capital P t. And we know this one is for f2. And what will be the canonical transformation? Here we have to find out the missing coordinates. So missing coordinate is small p and the capital Q. So the canonical transformation equations will be missing equal to dou f2 by present, that is dou q. And another one is missing is capital Q, that is equal to dou f2 by dou present, that is dou p. So what we get? P is equal to dou f2 by dou q, that is capital P into sec square q. So we can derive this equation, that is capital P will be equal to small p by sec square q, that is p equal to small p into cos square q. And what we will get for capital Q? We get capital Q is equal to dou f2 by dou p, that is tan q. So this is new set of coordinate and this is old set of coordinate. Here this one is in the new set of coordinate and this is old set of coordinate. So this generating function f2 is transforming from new set of coordinate to old set of coordinate or old set of coordinate to new set of coordinate. So this generative function will relate the old coordinates and the new coordinates. Third example, identity transformation. First problem, generative function is given, that is f equal to qi capital Pi. So what is this generative function? This is nothing but f2, that is f2 is q p t. So what will be the canonical transformation? That is missing coordinate, that is small p equal to dou f2 by dou q. So this is equal to capital Pi. And second one, missing coordinate is capital Q, that is equal to dou f2 by dou present, that is capital P. That is equal to, we get qi. See here, all set of coordinate and new set of coordinates are same, p and the capital P. Here small q and the small q. So such transformation are called identity transformation. Another example, generative function f equal to minus pi qi. So this will be f of p q, that is it is f3. So what will be the canonical transformation equation? Missing coordinate is small q, that is dou f3 by dou p, and you find out the answer. And another one is missing coordinate is capital P, that will be equal to dou f3 by dou q. Here this will be minus, this is also minus. Find the answer. You will get same kind of transformation. Capital Q is related to small q and capital P will be related to small p. So both are example for identity transformation. Please do it by yourself. Okay. Fourth example, exchange transformation. So the given generative function f is equal to qi, capital Qi. So this one will be f of q, qt, that is f1, right? So what will be the canonical transformation equations? One is small p equal to dou f1 by dou q, and this is equal to capital Qi. And another equation is capital P, that is equal to minus dou f1 by dou q, that will be equal to minus Qi. Here you can see P is exchanged to Qi, and here capital P is exchanged to minus Qi. See, momentum coordinate is exchanged to position coordinate. Here also the momentum coordinate is exchanged to position coordinate. So such transformation are called exchange transformation. The coordinate will be exchanged. Another example question. Generating function f is equal to minus e raised to q minus 1 all square tan p. Find out the canonical transformations. So here you can see this is a function of small p and the capital Q. So this is f3, right? And what will be the canonical transformation equations? That is missing coordinate is q, that is equal to dou f by dou p, and it is small q, so this will be negative. So what we get? We get q equal to minus dou f3 by dou p, that is plus e raised to q minus 1 all square 6 square p. Here you can see this is a all set of coordinate, and it is expressed as a combination of old and the new set of coordinate. And I want to rewrite this equation in the form of LHS contains only new coordinate system and RHS contains only old coordinate system. So we have to rearrange this equation, right? So I am rearranging this equation. So e raised to q minus 1 all square is equal to q by 6 square p. So this LHS contains only new coordinate system. So I can rewrite this equation again, that is e raised to q minus 1 will be equal to root q by sec p, that is equal to root q into cos p, that is e raised to q is equal to 1 plus root q cos p. So I can apply the log on both sides. So I get q is equal to log of 1 plus root q cos p. So now LHS contains only new coordinate system and RHS is old coordinate system, right? This one is the first canonical transformation, and now we have to find out the other canonical transformation. So what is the missing coordinate? Here it is capital P, and capital P will be equal to dou f3 by dou present, that is dou q, and for capital P this will be negative. So what we get? We get capital P is equal to 2 into e raised to q minus 1 into e raised to q tan p. Now we can replace e raised to q and this e raised to q by this type. So what we will get? We get capital P equal to 2 into e raised to q, that is e raised to q minus 1, that is root q cos p, into e raised to q, that is 1 plus root q cos p into tan p. And here what is this tan p? Tan p is nothing but sin p by cos p. So this cos p and this cos p will cancels, and remaining we get capital P equal to 2 into 1 plus root q cos p into root q sin p. So now we got LHS is completely new coordinate system and RHS is in old coordinate system. Now some works for you. Find the canonical transformation of the following. First one, f is equal to p capital P. Second one, f is equal to q1 capital P1 plus q2 capital Q2. Third one, f is equal to lambda q square cot q. And the fourth one, f is equal to minus 1 by 2 q square tan square p. And fifth one, f is equal to minus 2 by 3 into 2 m square g into q minus q all raised to 3 by 2. So please solve all these problems. Okay. Generating function and canonical transformation. Type 2 problems. In type 2 problem, a canonical transformation is given and we are asked to find out generating function. Example problem. Canonical transformation is given, that is q is equal to p inverse and the capital P is equal to q p square. The question is to find out f of q q. Here the generated function is given, that is f of q q, that is f of q q t, and this is nothing but f1. And for f1 we now missing coordinate, that is p is equal to dou f by dou q, and another missing coordinate, that is p is equal to minus dou f by dou q. And I can find out this df. See, f is a function of q, q and t, then I can write df is equal to dou f1 by dou q into dq plus dou f1 by dou capital Q into dq plus dou f1 by dou t. So here I can replace these two equations by these two, right? So I can rewrite df is equal to dou f1 by dou q, that is dou f by dou q is small p dq plus dou f1 by dou q, that is minus p dq plus dou f by dou t. Here in the given generated function, t coordinate is not given, so this will be definitely equal to 0. So we got df is equal to small p dq minus capital P dq. Here in the question, what they are asked to find out? Find the generating function. So here we got the generating function in its differential form. So by integrating this equation, we can find out the f value. Now we have to substitute these given conditions in the equation of df before integrating. So what we get? We get df is equal to small p is 1 by capital Q into dq minus capital P, it is given, that is q small p square dq. And again we know this small p is nothing but 1 by So that is, this is equal to 1 by q square. So what we get? We get df is equal to 1 by q dq minus q by q square into dq. And to find out the f value, we don't want to integrate both of this term. Suppose this is first term and this is second term, then you don't want to do integration for only one term, 1 or 2, which is easier. That integration only you have to do. That is the tip to find out f is integrate only one, which is easy. So to find out f value, you can integrate the first term or you can integrate the second term. But look in the problem, which one is easier one? I think first one is the easier one. So I get f is equal to integral 1 by q dq. So I get this is equal to q by capital Q. You can check for the option 2 also. Again, you get the same answer. You please try. That is f equal to minus integral q by q square into dq. So to find out the f, you don't want to integrate both the equation. You have to choose the only one which is easy to integrate. Okay. Second example, capital Q is equal to q square and capital P is equal to small p by 2q, and the generative function is given. It is a function of q and the capital P, and the question is to find out the generating function. So it is given the generative function is a function of small q and a capital P. So what is the first step? Here we know the given function is a function of q and P. That is, this is nothing but f2, right? And the missing coordinates are P and the other is Q, right? So we can write the canonical transformation equation, that is missing coordinate is equal to dou f by dou present, that is dou Q. And another equation is capital Q equal to dou f by dou present, that is dou capital P. This is the step 1. Step 1 in solving this equation. Now step 2. Step 2 is we have to find out df. That is df is equal to, we know f is a function of small q and a capital P. So what we get? Dou f by dou q into dq plus dou f by dou capital P into d capital P. Now we have to replace these two equations by equation we got in step 1. So we get df is equal to dou f by dou q, that is small p into dq plus dou f by dou capital P is capital Q into dp. Step 3. We have to substitute given conditions in df. What is the given condition? Given condition is q equal to q square and capital P is equal to small p by 2q. So we have to substitute those conditions in df. That is equal to small p. Here this is small p. So we can rearrange this equation. So we get small p is equal to 2q capital P into dq plus capital Q is given, that is q square into dp. So we got two equations, 1 and 2. So by integrating any one of 1 or 2, you can find out the generating function. So you have to choose which one is easier. So first I am choosing the first one. Then what we get? F equal to integral 2q capital P into dq. So what we get? We get q square P. Suppose you are choosing the second one, that is f is equal to integral q square dp. What do you get? You get q square into p. So to find out the f, you can choose any one or two. Final answer will be same. So when choosing one or two, you have to consider one thing. You choose which one is easier to integrate. Here this one is easier to integrate. For this example problem, this is not much complicated, but for some problems you get two equation 1 and 2, and one of them will be very easy to solve and other will be very complicated to integrate. So when finding out f, you choose which one is easier to integrate. Okay, another example problem. Capital Q is equal to root q cos 2p and capital P is equal to root q sin 2p. And question is to find the generating function f, which is a function of small p capital Q. So what is the first step? First step is you have to find out the canonical transformation. That is, here the generating function is f of p q. So what is the missing coordinate? That is small q, that is equal to dou f by dou p. And here this q is small q, so there will be a minus sign. And another missing coordinate is capital P, that is equal to dou f by dou q. For capital P also it is minus, right? Now the step 2. In step 2, we have to find out df. Here f is a function of p and q, so df will be equal to dou f by dou p into dp plus dou f by dou q into dq. And we can replace this dou f by dou p and dou f by dou q by canonical transformation equations. That is, we get dou f by dou p is minus q dp minus dou f by dou q is capital P dq. Now this step 3. In step 3, we have to replace these terms by given conditions. So the given equations are, one is capital Q is equal to root q cos 2p. So we can find out the q value, that is root q will be equal to q by cos 2p. That is, q will be equal to q square by cos square 2p, right? So we get df is equal to minus q. Here q is minus q square by cos square 2p into dp minus capital P is root q sin 2p, where root q is again q by cos 2p into sin 2p into dq. So we got two equations 1 and 2, and you can choose any one of them to find out the f value. Here I am choosing the first one, that is step 4. Here I am choosing the second one, that is df is equal to minus q by cos 2p into sin 2p dq. So what we get? We get f is equal to minus q square by 2 into tan 2p. You can find out the same answer by integrating first one also, but it will be a little complicated, but you get the same answer. Okay, that is why I am telling you, choose the simplest one to integrate. Okay, in the above problem there is some chances to make mistake. So what happened? You will land on a wrong answer. So I will tell you what is the chance for making mistake. So in the step 2, in the earlier problem, we got df is equal to minus q dp minus capital P dq, right? And we know in the question q is given, that is q is equal to root q cos 2p, and therefore root q is equal to capital Q by cos 2p, and capital P is also given in the question, that is root q sin 2p. Okay, so what we have to do in this step 2, we have to substitute for q and the capital P. So what we get? We get df is equal to minus q. We know root q, so q will be equal to q square by cos square 2p into dp minus capital P, that is root q sin 2p into dq. Here this integration is over dp, so we have to consider this cos square 2p. But here you see this integration is over dq, so sometimes you do f is equal to minus root q sin 2p into q, because in this equation you can see any capital Q times. So sometimes you do like this, but there is a error. Why? Because this root q is a function of capital Q, that is q by cos 2p into sin 2p into dq. So now when you are integrating about dq, you have to consider this q time. Sometimes maybe you think this is independent of capital Q, so you find out this is the answer. But actually that root q is a function of capital Q, so you have to substitute for that one, then only you have to integrate, then only you get the correct answer. Okay, so this is a common mistake, so please be careful. Okay, this one is a previous SAR net question. Actually, we already solved this problem. One of the earlier example problem is this one only. Here, the only difficulty is, in this question, they are not given the generating function. That is, here they are given the condition, that is q equal to q square and capital P is equal to small p by 2q. But they didn't specify what is the functions of f. But don't worry, you can easily identify the generating function from given options. See, every option, given option is function of q and the capital P. Right? So the generating function is f of qp. So the first step, you have to find out p equal to dou f by dou q and q is equal to dou f by dou p. Then step 2, you now find the df, and step 3, you have to substitute in df. Here in this question, the only difficulty is not specified what is the generating function. The form of generating function is not specified, but that we can easily identify from the given options. In the given option, the generating functions are only the function of q and the p. One work for you. Q is equal to log 1 plus root q cos p, and capital P is equal to q into 1 plus root q cos p into root q sin p. Find the generating function, that is a function of small p and capital Q. Actually, this is the reverse process of one of the earlier example problem. So this is a reverse process of one of the earlier problem. So you please try to solve this. Okay. Finding new Hamiltonian. That is, through canonical transformation, the old and the new Hamiltonian is related by h prime equal to h plus dou f by dou t, where f is the generating function. And if there is no explicit time dependence on f, then dou f by dou t will be equal to 0. Therefore, we get h prime is equal to h, where h prime is new coordinate system, that is capital QP, and h is in the old coordinate system, that is QP. So this is very important equation. There is many questions in previous NET exam based on this equation. This one is a previous NET problem, and in the question they given a Hamiltonian in odd coordinate system, that is QP, that is equal to p square by 2m plus 1 by 2m omega square q square, and they given a generating function, that is f of qq, that is equal to minus q by q, and they are asked to find out Hamiltonian in new coordinates, that is capital Q and capital P. We know the relation between old Hamiltonian and new Hamiltonian, that is h prime will be equal to h plus dou f by dou t. See, in this f generative function, there is no time coordinate, so this time will be definitely equal to 0. So here h prime is equal to h. So to find out the Hamiltonian in new coordinate system, that is capital Q and capital P, we have to replace this small p and small q in this old coordinate system. So how we can transform this old coordinate to new coordinate? By canonical transformations. So we need a generating function for this canonical transformation, and that generating function is given, that is f of qq is equal to minus q by q. So what will be the canonical transformation equations here? Here q is there, so the missing coordinate is small p, that is equal to dou f by dou q. So we get minus q into dou by dou q of q raised to minus 1. So what we get? We get minus q into minus 1 into q raised to minus 2. That is, we get small p equal to q by q square. And the another canonical transformation equation is, see, missing coordinate is capital P, and it is equal to minus dou f by dou q, that is equal to 1 by q. So from this equation we get small q is equal to 1 by capital P. Now we can substitute this small q value here. So we get small p is equal to q into capital P square. So we got the relation between old coordinate system. So now we got the relation between old coordinates and the new coordinates. That is, small q is equal to 1 by capital P, and small p is equal to q p square. Now we have to substitute these values in our old Hamiltonian. What is our old Hamiltonian? That is hqp is equal to p square by 2m plus 1 by 2m omega square q square. Now we have to substitute the value of small q and small p in this Hamiltonian. So we get Hamiltonian in new coordinates, that is qp, that will be equal to p is q capital P square, so its square will be q square p raised to 4 by 2m plus 1 by 2m omega square q square is 1 by p square by p square. So this will be the new Hamiltonian. So option D is the correct answer. This one is another NET problem, and here the Hamiltonian is given. That is, given Hamiltonian is in old coordinate system, that is QP. So first we have to find out this Hamiltonian in terms of capital Q and capital P. Then we have to use the Hamilton's equation of motions. that is q dot equal to dou h by dou p, and p dot is equal to minus dou h by dou q. So we get the answer. So this is the procedure. Okay. So first you have to find out Hamiltonian in new coordinate system. So to find out this Hamiltonian, they given the generating function, that is f of qp is equal to q square p. So by using this generating function, we can transform the Hamiltonian in old set of coordinate to new set of coordinate. Then we have to use this Hamilton's equation of motion. Okay. Here the given Hamiltonian is h of q p, and it is equal to p square by 2 alpha q square plus beta by 4 q raised to 4. And the given generating function is f of q p, that is equal to q square p. So by using this generating function, we have to find out the canonical transformations. So what will be the canonical transformation? The missing coordinate is small p, that will be equal to dou f by dou q. So we get 2q p. And another one is capital Q, that is equal to dou f by dou p. So we get it is equal to q square. So from here we can find out small q is equal to root q, and by substituting this condition here, we can find out small p is equal to 2 root q p. Now we can substitute these two equations in the old Hamiltonian. So we get new Hamiltonian, that is h q p will be equal to small p square is equal to 4 q p square by 2 alpha q square, that is q, plus beta by 4 q raised to 4, that is q square. So here q will cancels, and the 4 and 2 will cancels. So we get the new Hamiltonian HQP is equal to 2 capital P square by alpha plus beta q square by 4. Now we know the Hamilton's equation of motion. That is q dot is equal to dou h by dou p, and p dot is equal to minus dou h by dou q. So we get q dot is equal to dou h by dou p, that is 4p by alpha, and p dot is equal to minus dou h by dou q, that is minus beta q by 2. So this will be the answer. So we get option B as the answer. This one is another CSIR problem, and here the question is to find out the dependence of q of t on t. So the question is to find out how the position coordinate varies with respect to time for this given Hamiltonian. So Hamiltonian is represent some system. So how this system evolves in time. So we have to find out the variation of coordinate. That is the question, right? So here what they given? They given a Hamiltonian in all the set of coordinates, that is QP. And what we have to find out? We have to find out new Hamiltonian, that is h of QP plus dou f by dou t. So through generating function we can convert or transform the old Hamiltonian to new Hamiltonian, and here they given this generative function and it is independent of time. So this time will be equal to 0. So now we got the Hamiltonian in new coordinates. Now what we have to find out? We have to find out Hamilton's equation of motion. So what is the Hamilton's equation of motion in new coordinate system? That will be q dot is equal to dou h by dou p. So from this equation you can find out the q by integrating this term, that is dou h by dou p, and you get a constant of integration also. And now you have to use the initial condition, that is at time t equal to 0, q of t is equal to 0. So by substituting this condition, you can find out the C1. And substituting this value of C1 in this equation, you get the relation for Q. So from this Q, you can find out which one is the possible graph. So this is the procedure, okay. And by solving this equation, you get Q is equal to omega t. So which one will be the answer? It is option D. That is Q is increasing linearly with the time. So option D is the answer. Don't worry, it is not a work for you. I will tell you how to solve this exactly. So in the question, they given the old Hamiltonian, that is h of qp, that is equal to p square by 2m plus 1 by 2m omega square q square. And they given the generating function also, that is f equal to 1 by 2 m omega q square cot q. And when transforming this Hamiltonian qp to new coordinates, that is Hamiltonian capital Q capital P, there will be dou f by dou t also. But see, in this f there is no time coordinate, so definitely this time will be equal to 0. So we get Hamiltonian in old coordinate system is equal to Hamiltonian in new coordinate system. So to find out Hamiltonian new coordinate system, we have to find out the canonical transformation equations. Through this canonical transformation equations, we can transform the old coordinates to new coordinates. Okay, so what is the canonical transformation equations here? Here you know this function, generating function f is a function of small q and capital Q. That is missing coordinate small p is equal to dou f by dou q, and another one is capital P is equal to minus dou f by dou q. So the first canonical transformation, that is small p equal to dou f by dou q. So what we get? We get this is equal to m omega q into cot q. And second canonical transformation equation is capital P is equal to minus dou f by dou q, that is minus 1 by 2 m omega q square into derivative of cot q, that is into minus cosec square q. So we get 1 by 2 m omega q square is equal to p by cosec square q. So we can find out this q is equal to root 2p by root m omega cosec q. So now you can see left hand side is old coordinate system and RHS is new coordinate system, right? And now we can substitute this q value here. So we get small p is equal to m omega q, that is root 2p by root m omega cosec q into cot q. So after cancelling these terms, we get small p is equal to root 2p m omega into 1 by cosec q into cos q by sin q, where we can cancel these two terms. So we get small p is equal to root 2p m omega cos q. So we got two relations, one is this one and another one is this one. So now we can substitute a and b in this equation for Hamiltonian. That is the old Hamiltonian h of qp is equal to p square by 2m plus 1 by 2 m omega square q square. So the new Hamiltonian h of q p will be equal to, we have to replace this small p by this equation. So we get it is equal to 2p m omega cos square q by 2m plus 1 by 2 m omega square q square, where 1 by 2 m omega q square is equal to p by cosec square q. So this time will be equal to p omega by cosec square q, and we know 1 by cosec square q is equal to sine square q. So we get this new Hamiltonian qp is equal to capital P omega. So we got the new Hamiltonian. Now we have to find out the Hamilton's equations of motion. So Hamilton's equation of motion in new coordinates, that is q dot is equal to dou h by dou p, and p dot is equal to minus dou h by dou q. Here we need only this one. So what we get? We get q dot equal to dou h by dou p, that is we get omega. That is q dot is dq by dt, and that is equal to omega. Therefore dq is equal to omega dt. So to find out q, we have to integrate, that is integral omega dt. So on integration we get q is equal to omega t plus constant of integration. So now we have to use the initial conditions. That is, at a time t equal to 0, in the question itself they are given q of t is equal to 0. So substituting this condition, that is this equation equal to 0 equal to 0 plus c1, that is we get c1 is equal to 0. So we get the final equation for q as q is equal to omega t. That means if we draw a graph between q and t, we get a linear graph. So as time increases, q increases. So this graph represents the time evolution of coordinate.